Hello, class. Mr. Kablan here again, and I'm here to begin the first lesson in a brand new chapter, chapter 2, which is going to deal strictly with triangles. And today is actually going to be a very familiar lesson to you because we will be talking about the Pythagorean Theorem. Yes, it's one of the favorite topics of math because it's the one topic that you actually see in every math course throughout your high school career here. So, yay. All right, let's get straight to it. And like I said, it is a familiar topic for you, so it's relatively going to be a review of it. So let's get right to it here. Now, what's important with Pythagorean theorem is that you can only use it for one type of triangle. So if you take a look at the diagram there, what we have an example there is a right angle triangle. Now, how do we know if something's a right angle? Well, a right angle triangle, well, if you look at the diagram and there happens to be a square in one of the corners, that indicates that what we have there is a right angle triangle. Now, when we're identifying the sides of a right angle triangle, the very first side that you should identify is the hypotenuse. And the reason for that is because it's easy to find. Okay, because with the hypotenuse, as you can see, okay, you basically have to look for the right angle box, okay, or the corner with the box that indicates a right angle. You look directly across from it, okay, the hypotenuse is going to always be located across from it. Now, other than that, another fact that most of you probably know already is the fact that the hypotenuse is also the longest side of a right angle triangle. Now, the formula, I'm sure most of you have seen it already, is going to be given the form of c squared is equal to a squared plus b squared. Now, of the three letters, only one letter remains the same all the time, which is the letter C. And the C always represents the hypotenuse. That's why for every problem that we're going to look at in today's lesson, I always label the hypotenuse first because you can label the other two sides as A or B. Doesn't matter where it is. In fact, this diagram over here, as you can see, the A is on the side going up and down, and the B is on the bottom. And in the examples I'm going to do for today, you will see that in most cases, I'm going to put the A in the bottom and the B on the side, just to show you that it doesn't really matter where you put the A and the B. But bottom line, the C is always going to be the hypotenuse. All right, and then we can use the Pythagorean theorem to solve for any lengths of the sides of a right angle triangle, provided that we have two sides, two of the three given sides provided for us. All right, so let's take a look at the questions here. Now, before we begin, please make sure you have your calculator ready and just familiarize yourself with two keys, which we've used many times already. Okay, the x squared key, which is the x with the tiny 2 in the top, okay, as well as the square root key, which is the little symbol. I'm pretty sure you guys are familiar with that because I introduced you that already. All right, so starting off with two basic examples, we have two right angle triangles. So the very first thing we're going to do is write down the formula. Now remember, when you're using that Pythagorean theorem, see what information is given to you already. So we already have our hypotenuse here, which is C. So we're just going to label the 8 here as the A and the 10 here as a B. Okay, now once you label the points, okay, substitute the points into the correct letters over here. And the next thing I'm going to do is just to simplify, take the 8 squared and square it, gives me 64, 10 squared gives me 100, and then from there, add the two numbers together. Now, for the final step, what we want to do here is to take the square root of both sides, but in your calculator, what you're going to do there is take the square root of 164. And when you do that, you should get an answer here of 12.8. All right, so for this next example here, again, always start off by writing down the formula. Now you notice that for this one, okay, we are solving for the letter B. So the first thing we need to identify is which of the two other sides there will represent the hypotenuse or the letter C. Well, if you take a look at the bottom right-hand corner, here's our box. So when you look across from it, this here is going to be our hypotenuse. So we labeled that as C. Okay, so since we already have a B, our 20 here is going to be our A. All right, and then substitute the numbers in. Don't forget to put brackets around them. Now you notice that for this one, okay, this one's slightly different than the last one we did, because you notice we now have a value for C and we have to solve for the B, which happens to be on the right side. Next step, I'm just going to simplify the numbers. So 24 squared gives me 576 and 20 squared gives me 400. Now I'm going to leave this B squared exactly where it is. So I'm going to take the 400, move to the other side, and then subtract it from the 576, which is already there. And that gives me 176. And last but not least, just like the previous example, we take the square root of both sides, and that's going to give us a value of 13.3 millimeters. All right. So you've seen for that these two examples, again, the difference between example B and example A is that example B, okay, we have to solve for side B. So you have the additional step right here where you had to take the number and then subtract it from the number that was already on the left side there. So in this case here, the hypotenuse was given, and we have to solve for one of the two other sides. Okay, in question C, okay, same thing. Okay, notice we're solving for side A here. So what we have to do here is to label the hypotenuse first. Okay, so our hypotenuse here, here's the top right-hand corner. Okay, look across from it. This here will be a C. So we have our A already, so the 22 feet will be our B. So next step, just put the numbers in. And as you can see in this example, okay, just like the previous example, okay, we're solving for a side other than C here. So we're going to leave this A exactly where it is and simplify the next terms here. So 30 squared gives me 900. 22 squared gives me 44. Now we're going to leave the A squared where it is. So we're going to take this 484, move to the other side, and then subtract it from the 900 that's already there. Gives me 416. Okay, and last but not least, okay, the grand finale, take the square root of both sides, and this will give us a value of 20.4 feet. Okay, so these are the three, again, three basic ways to use Pythagorean theorem to solve for the hypotenuse as well as the two other given sides here. All right, so we're just going to take a look at some word problems just to accustom ourselves to the kind of problems we'll be seeing in this chapter. And one of my favorite type of word problems is ones involving walls and ladders. Okay, in fact, this type of question you're going to see quite often in this particular chapter because, again, these ladders and walls always make good right angle triangle problems. So a ladder is placed on a wall which is 10 feet high. Okay, and the foot of the ladder is placed 7 feet from the base of the wall. Now, what the foot of the ladder refers to is the bottom of the ladder. So we're looking at the distance between the bottom of the ladder and the wall, which in this case here is 7 feet. So what do we want to answer in this question here? We want to figure out how long the ladder is. Okay, always start off with the formula first. Okay, now you notice that what we have here for the right angle triangle is that the ladder happens to be our hypotenuse here because it's located, okay, across from our box. So that's going to be the C here. So we're going to label the 7 here as the A and the 10 feet here as the B. Okay, and then put the numbers in. All right, and then we're going to simplify the 7 squared and the 10 squared. That gives me 49 and 100 respectively. Then we add the two numbers together. And last but not least, take the square root of both sides. And this gives us the height of the ladder or the length of the ladder. Okay, and don't forget to, since this is a word problem, please make a statement including the units on all word problems just to communicate your answer. All right, so this last word problem we're going to look at over here, okay, is going to be involving a ramp. So the new sports complex has to build a wheelchair ramp outside the front doors. The current stairs go through a vertical rise of 1.5 meters. And it tells us here, if the ramp is 15 meters long, how far from the sports complex will the ramp start? Now, always take a look at the question here so you can see how this diagram is going to look like. And again, what we have to do here is understand what these different words mean. So vertical rise of 1.5 meters. So vertical, okay, is a line that's going straight up and down. So what we have there is a vertical line of 1.5 meters, okay? And in this case here, the ramp happens to be the slanted side of a right angle triangle, so that's going to be 15. And what we want to do here is calculate the distance from the bottom of the ramp to the stairs. All right, so always start off by writing down the formula. Now in this case here, you notice that what we have to do here is to label the side C here, which in this case here would be the 15, because the 15 is the side located directly across from our square there. All right, so that would make the bottom part here to be the A and the B here to be the 1.5. Okay, and then from there we just put the numbers in. Okay, now the next step, we're just going to simplify the 15 squared, which gives me 225, and the 1.5 squared, which gives me 2.25. Now we're going to leave this A squared where it is. So what we're going to do in our next step is to take the 2.25, okay, move it to the other side, then subtract it from the 225 that's already there. Okay, that gives me 222.75. All right, and last but not least, take the square root of both sides, and that gives me a value of 14.9 meters. All right, and this wraps up this particular lesson. Example here. Yay! All right, so one thing I'm just gonna warn you guys. Okay, I'm very critical in terms of how I word questions here. Okay, so I'm very specific in terms of what words I use in order for me to communicate what I want from you. So in this case over here, if for whatever reason you see a question like this, all right, okay, please do not do that. I will specifically ask you to solve for side X, okay? So technically this is not incorrect, but I will be very specific with the language, all right? And that wraps up today's lesson here. So you can get started work on the review here in chapter 2, and I'll see you in the next lesson.